Welcome back to the channel, guys. I'm Travis Sylvester, and today we're going to be showing you guys how to do the panel seam delete on this 64. Before we jump into doing this panel seam delete, I want to tell you guys, if you get something out of this, please share it with a fellow coworker, a friend, subscribe to the channel. We're trying to grow all these technical tips that we're showing you guys. Today is what we're going to show and dive into is going to be how to completely remove this seam altogether to where you have a nice, good metal to metal finish with no gap at all. The other ways that you guys could eliminate this would be to weld this seam. That way you do not have that sharp edge, and then grind it smooth, dishing it out a little bit, and then using your body filler in this area. You can also use, some of the guys like the filler with the kitty hair like Evercoat makes. I forget the technical term of it. It will be in the description of some of the products. But going back to it, today we're gonna show you guys how to do all of this in metal where it's all one piece all together. There's gonna be a lot of very technical things that go into this. What tools are used? How do you know where you shrink, stretch? How do you know how to weld it? How do you use a different tool that maybe you don't have in the shop? How do you pivot if you're in your garage and you only have maybe a hammer and dolly? What are the ways that you could go about this? Now let's go back to, if you guys are starting this process and you already have, or you still have, the lead that is in your car. Would you leave it? Would you remove it? Etc. I would not leave the lead in the car, and the reason being is, if you look at like most cars, I would say 90% of all these older cars, all the window channels themselves are usually rusted, surface rust, they get pinholes. The problem is water sits in these areas because dirt collects in the weather stripping. Now if you have, let's just say in this area of the back window, the weather stripping is holding dirt and that water has built up into a pinhole or an area where we can get water or moisture into and underneath this lead seam, that's going to cause rust. And you would never see it at first glance. You would be stripping the car and then you would hit the lead and then think everything is hunky-dory. But again, we're talking about putting a very nice paint job on these cars. And if you were putting all of that over it, eventually it's going to fail. The lead will crack, you'll have rust pinholes that'll start to bubble and come back on you. So remove it. And the number one thing you want to do is make sure that you guys have good ventilation, a fan blowing because it is lead, it is harmful. Wear a respirator with charcoal filters, and then just come in with a little butane torch and heat it up. As you start to heat it through, it'll just melt right out. You can use a wire brush and completely clean this up. Once it's gone, it drips on your floor. By the time it hits the floor, you just break it right off. It comes off easy. Once you are clean into this position, how do we go about actually making the panel? Well, you can do this a few different ways. You can use chipboard, which chipboard is a little thicker. I get this stuff from Uline, and it's nice because you can break it in the break. You can use the bead roller to put contours and things, and it kind of holds a little bit of that shape just like sheet metal would. Now the other thing you could do, I like the construction paper. You can use whatever kind of paper you want, but this is going to show you a few different things. I always go off of a straight edge of the paper, and we're just trying to get the general shape of what it is we're going to make out of sheet metal to eliminate this seam altogether. You have two pieces that are put together and then spot welded, and anytime you have this seam, if you did any kind of filler work over it, you have the tendency to have them flex and crack. We're going to eliminate that failure area altogether. So a lot of guys are going to say, I've been doing this for 40 years and haven't had a problem. Well, I have physically had them come back cracked. So that is why I like the best practice. I'm also going to show you guys, we're going to go above the seam, and I'm going to make this roof line with this piece of sheet metal just to show you guys, if you have a rusted rooftop, how you would make that area even with the body line that has a curvature in it. Obviously you're not going to be doing it with a brake. A brake is doing a straight line in the panel. So we're just going to show you guys, and then when we actually cut this out, I will remove that top area, but at least it gives you a little bit of a insight as to how it goes. I'm going to use the straight edge of the construction paper to be held in on the flat. That way I can basically put this straight edge onto a piece of, we're going to use 18 gauge. You can use 18 or 20. 16 is too thick. You want to try to match this up with the sheet metal that's here. I tend to go to 18 because it gives you just enough of sheet metal that makes it a little bit easier to weld. It's a tiny bit thicker than some of the sheet metal you see on these cars. And when we're making this, you have the luxury of just using simple magnets to hold things into place and keep everything tight. The more precise that you get this cardboard or paper template to fit, the better that your panel is going to fit into the car. You can use tape, and you can put tape over this whole thing and pull it, but you will find that tape kind of keeps some memory and tension, and different things have different issues. But the paper is going to show us a few things. If you put paper over like this seam, we have these areas that wrinkle, right? Well, if we're going to be putting this curvature into it, and we hold it nice and tight in both directions, this wrinkle is going to show you with your sheet metal where you're going to have to shrink this area to be able to get this sheet metal as one piece to lay over nice and flat. The more magnets you use and or tape it down, the better. And we're going to make this piece bigger than what we need because we're going to be using an English wheel to put this little bit of curvature in here. All I really care about at this point is that this flat is nice and tight. I'm not worried about this top at this moment. Now I've stuffed this paper all the way down in this drip rail. We will be removing these drip rails at some point, and it will make it easier to weld this in. You don't have to if you're going to keep your drip rails, but we're doing custom touches to this car, and we are going to be cutting these off and welding that whole seam. Now, you can use a pencil, you can use a piece of chalk, whatever you guys want. We're just trying to get a precise curvature of this body seam from one end to the other. You can use your finger, whatever works, but I like the pencil, even though it has the yellow on it, will actually leave the yellow on the construction paper, but this is giving you a very good representation as to where that line needs to be. I'm just going to pull the paper so it has tension tight in that area. And then right here you can feel this is where our seam is underneath. I'm just going to put a couple reference marks outside of that so I can keep track of where it is. It's up in here, above and below. That way I know down here I can basically eliminate this excess paper. Now we're going to be tipping this edge in the bead roller, and I don't really need all this excess. If we're trying to shrink metal, you want to dissect each piece as to where you're going to be welding it. I've seen guys where, and I'm guilty when I started out, I used to do the same thing. If I had a complex curve, and there's nothing necessarily wrong with that as long as we all get to the same end goal, maybe you make this piece out of one and your roof piece out of another. But if we're trying to make things look as clean and as perfect as we can, you put those two together and a lot of guys will just weld the seam. And as long as you're a proficient welder and you can grind the thing close, our body filler will be able to take care of any little inconsistencies. I want to make this where you don't have any weld seams that are trying to create a nice crisp body line. I want to actually tip this in the bead roller, and we're going to go in enough room. Now, if you had back access, like I don't have back access inside this panel, so we can't get in there and hammer and dolly it to make our weld seam perfect. but what I can do is get it out away from the seam to where we go in about 1.5 inches, give or take, to leave that excess metal to bring it up over the rooftop, and then you can weld it nice and flat and a good butt weld to the roof line itself. So again, I'll just make some reference marks outside where I need it. Now, if I needed the window channel itself, I could account for a little bit more metal. This window channel is in pretty good shape, so I don't have to worry about it. But if you needed it, you could make this all in one piece that's going to wrap around and even have those bends in it as well. Tell you what, we'll do it just so that way you guys can see it in case you needed it. We'll leave this a little bit longer. At this point, we are going to remove this. We now have this body line exactly where it needs to be. Now that we've gotten our piece cut out, we've made this piece obviously a lot bigger, but the reason that we made it bigger is because we have to put this thing in the English wheel, and I want to make sure that it's going all the way to the edge with the right shape. Now, when you're making a panel like this, could you just take a flat piece of sheet metal and put it over this, trace it out, cut your piece, and then set it in and weld it? Yes, you could, but if that panel has more shape to it than if it's not flat, when you go to weld it, it's under tension and all of your welds are going to look wavy and you're going to fight highs later with the bodywork stage. We also want to make a point that you do not want to cut any of this out until you have your new piece made, set in place, because everything we do from MIG welding or TIG welding this in, you want it to have the tightest tolerance absolutely possible. You want 0 gaps if you can. The more you do this, the better you're going to get. But we're going to show you guys all the things to think about while you do it to be able to get that perfect fit. I put the radius into this panel so that way, and I set it back, leaving me a little bit of excess on the end. Now, when it comes to shape versus form, what am I referring to? Form is if you are curving a piece of sheet metal in one direction. So maybe you take this sheet metal and you just bend it over your knee. That would be form. Shape has a contour in more than one direction. In this case, how do you check that? Well, if you have a radius gauge, we're going to be using the JRM radius gauges that come with his planishing hammer. These have a lot more of a fine tooth of making sure that you are getting the exact shape that you need, especially when it comes to planishing hammers. There's a few different ways that you can make this, and a planishing hammer is one of them. I like his gauges, even though we're going to use the English wheel for this one. It shows you what wheel that you need to pick. Now, how would you know? If you take that radius gauge and you move it back and forth across the panel, you're verifying that you see no air gap in that curvature. Now, in camera, this probably looks flat, but this is actually a 48 radius, so it is a very, very low crown radius. Now, we went this way, and we're going to check it up and down, and it does, in fact, have a 48-inch radius curve in both directions. That's how we know we're going to shape this panel to this 48. Now, we are going to wheel this out, and again, I left excess to make sure that we get that shape in that area. That's why I have Sharpied that area out. We're going to focus there to put very light pressure to get this exact. You want this to be exact as you can to lay in there relaxed. If you have it under tension and you just force things, it's going to have problems later when you weld it. So we're going to go over the English wheel and show you guys the next steps. Okay, we've verified that we have a 48R radius on our gauge for that panel. Now, we have the metal ace that we got at Trick Tools. And how do you go upon picking which one of the wheels that you're going to use? Well, you're going to take that gauge and basically match it up to whatever die. Now, all of these dies have a different size crown, from flat maybe you're just trying to flatten a panel, to maybe you're trying to put a ton of shape into something. Obviously, we are not going to use something like that to try to form this panel. It is easier to shape something with a whole lot of curvature than it is to do something with a very low crown. And although we are still very green to the English wheel, we're learning as we go as well. We matched up this with the lowest crown die. Now, some of the things to think about is anything, especially in a body shop like we are, all of the dust that's on this wheel will transfer into the metal, and you want the metal to have the best finish that you can. This stuff's a no-no in a body shop. So keep it, I always spray it on the rag, keep it very tight, because any of these little tiny particles that float over into other cars that are in the finishing stage will fisheye paint so bad, and you'll not know why. You'll think it's in your airline. It's actually your WD-40. So be very cautious when it comes to using this. And also make sure that your panel that you're about to wheel is completely clean, because any bit of the dust that is on there will transfer. It'll transfer to the wheel, and then it'll just stick in there and keep messing up your panel. I am going to start with the panel. Obviously you can see the shape. We're going to be using this area of it. I'm using all this, and this is excessive. Again, I'm very green to the English wheel. I'm using all this as an area that I can kind of just stay focused in, and this is more or less the handle to be able to move. This handle below will bring your wheel up, and then your foot pedal down here where your wheel is will bring the lower contact wheel up to the top wheel. So what you're going to do here is just keep sliding this back and forth until you can see that it's making very little contact. This is where I have messed up in the past when I was trying to figure this thing out. Especially with a low crown, this takes very, very little pressure. You almost don't think you're doing anything, but it's slowly stretching in the center. All the videos we talk about with hammer and dollying and being hammer on dolly and stretching metal, this is doing it, but you're going to be doing it linearly, and it's only going to be doing it in the center of these wheels. So the tighter the pass as you guys move through, the better this finish is going to be, so it doesn't look choppy. The other options that you could do to do something very low crown is with a planishing hammer, where it is planishing it. The JRM hammer is what we like. It's what we use. And because we're trying to get used to this new wheel, that's what we're going to show you guys. So you can see it's still slipping. I'm going to just creep up on it. And again, I made our reference marks a little bit beyond. That way we can keep our shape right. Because if we know we have to have the shape all the way to the end, I don't want to try and get that to roll right up on the edge. You want to leave a little bit more excess and then just stay in that pattern. So you want to walk this panel through. This in itself, if you guys have not done an English wheel, is a bit of a challenge for tracking. When you track, it's funny because every time you think you're going to move the metal to go in that direction, it does the opposite. And it's because you need to, it's muscle memory. You basically make your little move and then you go back and forth. So we've gone through, we did just a couple passes, very light pressure, almost to where we feel like we're not doing anything, so that way we can verify whether we've made any stretching or not. You can take your gauge and just make sure that you do see air gap, right? This isn't the flat gauge. It does say 48 on it, and you're going to be bringing it over to the area that you have shaped, and there is still a very slight air gap, but it is an improvement from what tiny little bit we have. We're going to be checking it in both directions with the gauge to make sure that we've caught everything that we need, and creep up on this very, very little bit at a time. I'm only going to be moving the foot wheel upward with pressure, just a hair each time. Now that we have ran the panel back through the English wheel a few times, it does not take much. I'm only moving that bottom wheel an inch or so at a time. It is very, very minimal. But I want you guys to see from a side profile, this area that we focused on, I was not running the wheel beyond much of that Sharpie line because we're only going to use that area for the actual shape. With our paper template that we have our pencil reference mark for this curvature, I now want to transfer this piece that we're going to use onto the shape that we've already formed, or I'm sorry, shaped. We did not form it, we shaped it. So you need to cut this as precise and as possible. Just make sure. We've got this panel fitted onto the B-pillar of the car, and as you tip this edge to fit, as you're rolling it through your bead roller, you are going to want to do that very little bits at a time, forcing the metal upward with one hand to be able to create that shape that you're trying to get to fit the roof line. As you do that, if you were to pull too hard upward on the panel, you end up wrinkling and causing more damage than going slowly, little bits at a time. As that starts to wrinkle on you, you are then going to be using your kick shrinker and shrinking those areas that start to buckle and bow outward. The other alternative to that would be using the tin snips and pie cutting out small areas at a time. Maybe you even use a cutoff wheel, so that way you can bring the metal back in on itself to shape it. Obviously, using the shrinking kick shrinker is going to be the best and easiest, but not everybody has that in their shop. The other thing is, as you are tipping it, maybe your edges on each end of the panel are not getting quite as crisp as the center. You can always go back to your toe dolly and use an edge of a bench and clamp it down, and then hammer and dolly that edge back nice and crisp, so that way every time you enter the bead roller with the panel, you have a consistent shape. And if you didn't have a bead roller at all, you could also sit there and slowly put the toe dolly on your Sharpie line, so that way you can continue to bend it right on that exact mark, creating that body line. As you get this panel to take shape, you can then, it's going to be a constant back and forth, putting it on the car, go back over, shrink a little bit more. You might have to tip or use a hammer and dolly on the car. You'll take the panel and fit it, and you can just tap it into shape, and then you're actually going to be stretching this top edge, getting it to set in more and more. It's a constant back and forth until you get this thing to fit relaxed to where you do not have to push an edge into one another on itself. When you get to the welding portion, if it's all bound up, it's going to cause warpage, and you're going to see deflections in the light on the panel when you're all done. If you make notes on your template, when we were first putting this on here, when you had this as one piece and you folded it over and you fold the paper in on itself, that's also showing you where those points of shrinkage is going to have to happen, whether it be a pie cut or whether it be a kick shrinker. It's giving you all the data you need from this paper in the very beginning. Something that I will do too is when you put it on the car and you force it in on itself, it will then bow in those particular areas that you know you can just go back in and shrink. It's just, if it's not a big deal. If you're learning kick shrinker, you have a stretcher teeth with it as well. So if you go too far in any one direction, you can just swap the jaws back out or buy a whole nother unit and then just correct what you do. The cool part about metal is if you mess it up, you just go in the other direction, whether it be heating or shrinking or beating it back into shape. It doesn't really matter. It's not like woodworking. Otherwise, we'd have a lot of glue. What we're going to do next, we're going to then mark just a rough area of what we're going to be affecting. we're going to prep all of our metal with a DA with 80 grit and clean everything and get it ready for cutting and welding. If you're stripping your car and you have excessive paint buildup, bodywork, whatever it may be, use a strip disc. And the reason that we use the strip discs is because you can get them for the Roll-Lock, the 3-inch, this one's a worn out one. You can get them for a bigger Makita grinder. You can get them on an Eastwood SCT, the barrel sand, it's the 40 grit one. All the other grits don't really work that hot. But you can then strip all the paint off to prep it. The reason that we use the strip discs is so we're not removing metal. And I know I did take 80 grit on a DA right at the end just to dig into the metal very little bit to clean it. But the whole purpose here is that you're building the panel to the points of where you have good metal. If you have a small hole, you don't want to be trying to make that patch as small as possible and you have a bunch of pinholes and areas that are worn away where the metal is not as thick as the good metal. You want to go to where you have good metal, especially if you're going to TIG weld it. TIG welding doesn't like any kind of dirt or grime. It'll contaminate it. The gas will sputter, pop. It'll land on your tungsten. So that is why we took these steps to clean it. Now, I know I showed you guys how to make the entire sail panel in case you need it up higher. But for this particular purpose and this car being a California car, we only need to replace this seam where it wraps around. So I am going to take this panel and I'm going to cut it and fit it, and that's how we will show you guys where this is critical on making fitment perfect. We've got this rough cutted out for the area that we're going to use only. Now, the things that you should consider when you're trying to get that perfect butt weld fitment where you don't have gaps and inconsistencies everywhere is, what is the metal going to do as this sinks into this sail panel? When you bring this panel down into there, this edge is going to go that way. So if you just set this exactly where it's going to be and you're not taking into consideration that when this goes in, you're going to have to remove more on the back side of this downward piece, that's where it's really, in my opinion, critical. And it's only going to move the thickness of the sheet metal that's actually there. So what I'm going to do is I'm going to sight this in from the side, verifying that this break in the metal where we tipped it can move laterally in instead of having this sit on top of. That way, this does not shift too far up and then there's a gap or we have to grind more. We're trying to make this thing drop right in and have a perfect fit. In doing so, we're then going to remove this panel. We're going to be using a Dicom spray, which is a layout fluid, and then the next thing will be a scribe. Now, you can use a Sharpie and just Sharpie this thing and be fine, as long as you are remembering what side of the Sharpie you are grinding up to. For example, if I take this panel and I Sharpie around it, when you actually go to cut it, I will use an air saw or a cutoff wheel. Hey, look at there. If you're coming in and we are just marking this, when you actually come in and cut it out, cutoff wheel, air saw, whatever you guys want to use. When you come back in with the actual die grinder, we're going to put 36 grit or 80 grit, whatever you guys are comfortable with. Obviously 36 grit is going to take a lot more material. And you're going to then sit there and very carefully grind this roof away until you reach that edge of the Sharpie. I'm a fan of both. I want to show you guys every way possible. A scribe is basically a sharp carbide metal pencil, and we're going to spray the area and we're going to be scratching this. That way we have a very defined line that we're going up to. If you doesn't really matter which way you decide to do it, but I'm going to scribe this over the dicom, and then we're going to rough cut it out, and then we're going to carefully set this panel in, and then we will make this cut on the back side. Get this to set in first, it drops right in. Then cut the area that's going to grow. We've got everything cut out and fitted now, and we're going to be talking about the details of how we got there. We used a cutoff wheel, rough cut everything around the perimeter, staying about 1/4 inch away. And I didn't use this cutoff wheel, I only used it to put one hole in each direction of the cut. I then came through and I used the air saw. And the reason that I use the air saw, especially if you have room to get in there, is because the blade thickness of some of these air saws are thinner than a cutoff wheel. So you can be, one, more precise, have less gap. Maybe you have to come back in and you made a mistake and you have to put the panel back in. You're not losing very much material, especially if you're going to MIG it. And even if you are going to TIG, it's not going to make a huge difference. If you have a shallow area where there's a piece of metal behind it, you can always cut your blade down with a pair of tin snips so that way you can get in there. As you move through, we started finding that the center of that seam had the spot welds, and typically those are just pinch welded together from the factory. This particular one was actually through to the bracing for the entire roof, and I know a lot of you guys are going to go, I don't want to do that because you're losing the integrity. Well, keep in mind, this entire structure is all the way through the duration of the windshield, around the doors, everything. It's all one piece. The only area that we are losing is there. Now, you have to sit here and go, what's worse? Is it better to leave it and we might have a potential rust issue? Because yes, you guys saw it looked good and clean, but as soon as I removed those spot welds and removed it from the inner structure, there was a whole bunch of dirt, grime, and rust held back there. One time of getting in the moisture and that stuff starts to seep, it will start causing those pinhole bubbles to come back on you. So in my stance, we keep the structure with using all of the windows and all the spot welding that's already in place. We're eliminating a potential failure issue, not only with using filler, not only using lead, we're going the best route and we're making this where there's almost no body filler, just a skim coat, and we're coming through and being very precise about it. I do really like the Steck. This is S-T-E-C-K is how it's spelt, and these are a hardened steel that there's a couple different ones. There's a straight one and they have a blade to where you can then go through and remove the spot welds. When you're removing the spot welds, you can use one of these Blair tools, which I think the Blair tools are probably the best. They're a carbide, more of like a machining end mill with a drill bit in the end that's spring loaded. You can use these, and as these wear out, they'll start to walk. And in this case, I don't care because I'm not saving the panel. If you're trying to save the panel, put it back in, this is more the route that you want to go. I don't care. We could go right to demolition with this guy and a cutoff wheel. So I just took the cutoff wheel and worked it on the weld itself. always making sure that as you guys are working, whether it be a cutoff wheel or a die grinder, you are using two hands to stabilize yourself on the car. As you creep up on that scribe mark, I'll start with like a 36 grit on the 3-inch die grinder. And as I get closer and closer, I will dial it back to an 80 grit so you're removing less material at a time. And then finally, you can then go to a file in which you can fine tune it if you have the room. So as you get it fitted, you might find and run into areas that have where you don't have access or you can't fit that cutoff wheel in there. At that point, I'll start going through and I'll take a Sharpie and I will actually mark the panel where I know from point A to point B, I just need to take a sliver off and I will start to remove them on the panel. But again, I try to make sure that everything is reliant on my scribe mark and I'm not going back and forth. As soon as you start going back and forth, you start losing that exact shape, or maybe it's time to wipe off all the dicum, set the panel back in, remark, and make any adjustments on your hole. You guys can also use a barrel sander. You guys will also notice that I have radiused the corners, and the reason that I radius the corners on the panels as much as I can is because if you're welding in one direction and then you switch and you come back down, and where those points meet, you end up with more heat in that area, which is going to cause a heat wave in your metalwork when you get done and you metal finish it, especially if you're hammer and dollying it, where if you make it one continuous weld seam that's smooth, if the heat and the warpage will work itself from one end to the other, and you're not going to fight that as much for those two ends coming together. If you are trying to make an adjustment and maybe the seam is covered by the panel, stupid little trick, take tape with your panel off and put it across those 2 point references. Even if it's a curve, at least it gives you a general idea of where you're going to be cutting. And then when you put the panel back over it, you can go to the farthest ends that you see and you can tell where your tape is to make a reference mark, and then you can shear, cut it, grind it, whatever it is you guys got to do. The next part we're going to go into is welding this thing up. Before we jump into welding this, if you already have access to the inner structure, clean it up with a stripper disc, treat the rust with either a rust mort. In this case, this one cleaned right up to bare clean sheet metal. We went right to a SEM product, which is a copper weld. You can actually weld this. It does not weld pretty. Me personally, I a lot of times will still clean off my edge. I really don't like to weld to it, but it is a good protective for anything behind. You do have to take the preparation and clean all of your dicum, all of your Sharpie marks. It will affect the weld. It doesn't come out as clean. And if you guys are, because a lot of guys are, they're taking a die grinder and they're cleaning up all of their metal with an 80 grit roll-lock. If you do that, you're already having problems with sheet metal. You're going to have even more problems because you just made it thinner. We're talking about 40 to 60 thousandths of an inch the sheet metal is, and if you're using 80 grit on there, it's going to be even worse because you're trying to weld paper. Use a strip disc on cleaning all of your metal and try to take as little amount of material away as you can. We're going to fit the panel, tack weld it every ½ inch, and then once we get everything fitted, making sure it is exactly flush from each side, we will then go through cooling every weld. If you guys haven't seen it, we've done a tutorial on MIG welding itself, and check it out. There's a lot of really good tips. We're not going to dive too deep into it. We're going to take you guys through the process. We've got this panel welded in, and as you get the panel to fit into place, I always start tacking it in the areas that fit the absolute best. You may have to just move the metal in or out so that way they are completely on plane with each other. The better you can get that, the better the end result is. Now, we did not have any back access to this, so could we have gotten this even better in the metal finishing? Absolutely, but making sure you have a couple different tools, a little flat blade, or even a pick, whatever you can get into little areas to make small adjustments, and then go around the perimeter tacking it in until everything is tacked in within a ½ inch of each other. Doesn't matter whether you're TIGging it or MIGging it, you need to tack the whole thing in so nothing starts shifting. As you start welding this, things are going to start to move. And as you start to go around and cool your welds, I will tack and cool. Now keep in mind, you'll see me kind of do it every one, and then as I kind of get in a rhythm and things are more tacked in, I will start to jump from one end to another. If you're just putting one tack, you're not introducing a ton of heat to it. So as long as I'm jumping around in distance from each other and not staying right next to one another, sometimes I'll do 5 or 6 tacks and then I'll come back in and cool the whole panel with the air. But the more you do the air, the less warpage you're going to have. There is a level of warpage here because, like I said, we don't have any back access. Once your tack welds are all connected, these are kind of hard to find, and any of the tools and supplies that we're using in this video, check the description, we'll have links to it. This is a grinding cutoff wheel, so it's about 250 thou or a 1/4 inch thick. We use those and we use it on the top of the weld. That way we're not making the areas around the weld thin. And you use your roll lock with a 36, again, I creep up to it. So I'll use that cutoff wheel to grind the bulk of it down. Then I go to a 36 and then to an 80. And then these things are not cheap. As you get to a point where your disc is wearing down, you can take a pair of maybe retired tin snips that are older, because it is going to dull them out, and then cut into a hex. I've seen guys cut them into a star, and you can actually take the weld out of a 90-degree area and round it out. There's all kinds of little tricks for cutting these things up. We will pivot and use on the back sides of these, one is a smaller diameter than the other. Just know that when you're actually grinding your weld, maybe you're trying to grind in one specific spot, you're going to have more control with the back pad that goes all the way to the distance of the end of this. Sometimes I want to use the bigger disc on the smaller backing so it creates a curvature into a panel. Just depends on what you guys are doing. Once we have carefully taken it down and we're not making things thin, I come back through with the DA with 80 grit, sticky back, and I just kind of finish things out. The one thing I want to make sure you guys do is if you've used Dicom or anything else in this area before you go to primer or body filler, you want to make sure all that stuff is off, because nothing will stick to that Dicom in the long run. Continue to learn, share what you know, and we will see you guys next week.